question was the tennis ball bouncing n times on the ground. So the common ratio for this one, so the first term was 80 and 60, and it's obviously going to get smaller and smaller. So you're expecting a fraction ratio. So R would be H2 over H1, the first height, second height over the first. That was 60 over 80, and that would give 0.75. So hopefully that was okay. And then part B, you're looking to find the height of the ball on the 10th time. So that would be this happening 10 times. So you're looking for, I suppose, U10. So the nth term in general would be I'll use this formula, n minus 1. So the first term was 80 centimeters. The ratio you just found was 0.75. And if it bounces 10 times, it's going to be 10 minus 1, which is 9. Calculator out. And it approximately equals 6.01. Okay. Heavy shadow here. Maybe I'll turn off that light. 1 second. All right, next part. You were looking at the total distance. So this had a little trick to it, up and down. So you needed to use the sum of terms in geometric. So let's just write the formula. 1 minus R. Okay, so the key here, well, if you did the sum of terms, you'll only get, well, you won't get the total distance, will you?
No, because you have to just multiply by 2, right?
Yeah. So you got to get distance up and down, which is going to be mirrored, of course. So that's if you just wanted to find, I suppose, up distance or distance to the ground on each one. So up and down would be twice that. And then that's another calculator job. 52609, I think. So hopefully that was okay. That's probably the easiest of the questions. All right. Any questions there, Tamara? Are you okay?
Yeah, I got everything for question 1. It's just after that I was kind of confused.
Okay. All right, so let's move on to question 2. Let's get the question up on my screen. Okay, so question 2. So more than likely, if a sequence and series question does come up, it's going to involve something else other than just number. It's going to, as you see, this question involves some logs. Next question involves some trig. And the last question was involving compound interest. But let's do this anyway. So question 2, find the common ratio. That's just going to be our, well, U1 is ln x to the 9, and U2 is ln x to the 3. So you can use the rules of logs. That's going to be 9 ln x, and that's going to be 3 ln x, I suppose. And then U2 over U1 would give me the ratio. So it's going to be 3 x over 9 ln x. That's U2 over U1, and 1/3, I think, with some cancellation.
Yes.
Okay, part B. Solve this. Sean, did you get an answer here?
I did get an answer.
What was the answer?
X equals e to the 2 over 3, or 1.95.
Okay.
Is that not right?
No, I'd say you made a small error. Tamara, did you get an answer for this?
No.
Okay. So there's some sum of terms to infinity starting with k equal to 1, and this is given in the question. 3 minus k ln x is equal to 27. What does this all mean, Sean?
It means that the sum of that is equal to 27. So 3 to the 3 times ln x plus 3 to the 2 times ln x plus 3 to the 1 times ln x, and so on.
Okay. Yeah, so it directly relates to the part above. It's this part. We just want to look at this part. How does that relate to this? Well, if you find the UN, the nth term, based off the information we're given, we have 9 ln x. The ratio is 1/3, and n minus 1 then would be still n minus 1 because we're not entirely sure. Okay, so that's the nth term, but it doesn't look like that yet. But with a bit of manipulation, we can...
oh, it is the same thing, yeah.
Yeah, we can see that that's 3 to the minus 1, isn't it? So that's 3 to the minus 1, which will make that plus 1 minus n. So that's, you can put that in front then. Just I can do that as a side note. 3 to the minus 1 times n minus 1, and that will give 3 to the n 1 minus n, is it? 1 minus n. What about at the ln x part? Well, that's... Is it the same? It is the same. Why did I'm doubting myself now. ln x to the 9. No, it's just 3 squared. Yes, that's how you do it. Sorry, I've forgotten how to do it. 1 minus n, that's going to be times 3 squared, isn't it? Times ln x. So I'm trying to get it to fit this. And then we can combine these two to give 3 to the 3 minus n ln x. So it is just the sum of this sequence. It is just the sum. It's telling you the sum to infinity of the sequence is 27, because we can see that that's the same as that. So you can use the sum of terms formula, and that's possibly the key here. So sum of terms to infinity. So that's the first term over 1 minus the ratio. So we have the first term, 9 ln x from before, and that's 1 minus 1/3. Now we know from this, we can say that that now equals 27. Is this the way you did it, Sean, or you did? I presume you did.
I did do it like that, but then I had rearranged it incorrectly. So I had it be 3 cubed times 1 over 3 to the n, and I forgot that it had to be n minus 1 for you to be able to...
Oh, yeah. Okay. Yeah. Yeah, so then once we notice that this is just the sum of terms, we can use the sum of terms, and that will also equal 27. So rearranging this, and we can try and solve this for x. I think multiplying up by 3 and common denominator here, you get 27 ln x all over 3 take away 1, and that's still equal to 27. Manipulation of this. So this is 2, and there's 27 there, so it's 27 over 2, and that means ln x is equal to 2. And therefore, x is equal to... what would x be equal to here, Tamara?
So can you move the paper a bit to the left?
Yeah. Am I off screen?
Yeah, a bit. Okay.
Oh.
Thank you.
Okay. So what would x be here?
E squared.
Oh, thank you, Sean. Yes, e squared. Yeah. Okay, so yep, that one definitely. So don't be scared of the sigma notation. Just means sum, and this is clearly sum to infinity. So if you see this in a sequences question, you can use, and it is a geometric, we can use the sum to infinity formula. Then just had to make that match, and it did with a bit of manipulation here. Okay. By no means easy, that one. Okay, so but
Wait, so in the booklet they write the formula as u1 over r minus 1, not 1 minus r.
Is that going to make a difference?
Wouldn't it change the sign?
It would, but isn't there like a note in the formula? I don't know. There should be a note in the formula. If
It says that that absolute value of r is less than 1.
Let me just check the formula. is it? Oh yeah. Yeah, so it should give the same answer then, because it's the absolute value of, well, wouldn't it give the same answer, the absolute value of R then?
Absolute value of R is
Yeah.
less than 1, so that would mean that the bottom has to be negative, right?
Oh, negative. That's if. So if U1 was or minus 1, was it saying? Therefore, it would be 9 ln x all over negative 2/3. So it would be e to the negative 2?
Yeah, which is something completely different.
It is something completely different. I know there's a... Why would it be... That wouldn't work. Yeah, I think... I didn't refer to the formula. I always do this way, so you get, and the other way, if it's a negative, I always go with the positive. I can't remember exactly why. It's like an unwritten rule in my head. So if you have a ratio that's, because the sum wouldn't be,
The sum wouldn't be negative, yeah.
no. So you make it so this bottom is positive. Let me get back to you on that one, but that's the way I always remember. So if it's if it's more than 1, I would use the way it's written in the formula booklet, and if it's less than 1, I would use this way. And that was
if it's more than 1, we wouldn't be able to find the sum to infinity, would we?
No, that's correct, actually, yes. If it's more than 1, oh, that's the one above, the formula above, isn't it? The or minus 1
Yeah.
minus or. That's the one you do more than 1. Yeah, I'm not sure. Let me look into that. I can't remember. I had written it like that, or written it like this from memory. I'll look into that. I can't remember exactly why and what's the story, because that would be a different answer, but I think it would be the wrong answer. I'll check that out. Okay. Let's move on anyway, and I'll get back to you on that one. Question 3 was the one with trig in it, wasn't it? I've turned off the air conditioning here. That's why it's so warm. I'm on Word. Okay, so question 3 then. Okay, so start with you, Tamara. Did you get an answer for part A? What did you get as the ratio?
I think I got the expression, but I didn't get the ratio.
Oh yeah, what was the expression? So yeah.
4 over 5 sine squared theta?
Yep. Yeah, that's it. So or is just going to be U2 over U1, same as usual. When you simplify that fraction down, you get 4 sine squared theta over 5. Okay, so that'll be the first part. So an easy start, but I don't think it continues in an easy fashion. So it's more of a trig question, really, this. Applying rules of series. Find the possible values of or. So there's some information in the question for or. It says theta cannot be between, or is between 0 and 2 pi, and it can't be, theta cannot be pi. And the translation of that is that the sine of theta will not be 0 then, won't it?
Yes.
So from this, we can say sine squared theta is going to be between 0, sine squared theta is going to be between 0 and 1 then, isn't it?
Yeah.
It can
Then
be,
we can just multiply that by... Yeah, it can be 1.
Yeah, and then if I just multiply everything by 4/5 to get this 4/5 thing, I can see that it's going to be just 4. So multiplying 0 by 4/5 is 0, and then it's going to be just 4/5, and this, of course, is the ratio. So 0 is, or is between 0 and 4/5. That's what I got anyway. Yeah, so that was, not perhaps immediately obvious what to do there, but that's more of a trig issue if you weren't getting that. Part B then, show that the sum of the infinite sequence is this. Did you manage to do this, Sean?
Well, the first answer I got was negative because I did r minus 1 instead of 1 minus r. But yeah, I did get it.
Okay. Yeah, so the sum to infinity, and I automatically went to 1 minus sine squared theta all over 5. So that's the sum to infinity, just from the formula. The first term is 20, and this is our ratio. You can do a little bit of rearranging of that, and you get 100 over 5 minus 4 sine squared theta. Now, the question, it said, show that it equals 100 over 3 plus 2 cos 2 theta. So we have an option here whether we try and manipulate this to look like this or manipulate that to look like that. I did this one to look like that because we have a cos 2 theta in our known identities on double angle formula for cos. So the double angle formula for cos from our formula booklet. So I'm converting this, so I'll just rewrite it here. 3 plus, no, I'll leave out the 100 because it's okay. 3 plus 2 cos 2 theta. So from the formula booklet, this equals, what is it, 1 minus 2, so it's 1 minus 2 sine squared theta. So we can already see it's looking like that. And multiplying by 2, you get 3 plus 2 minus 4 sine squared theta, and this is looking good, to be 5 minus 4 sine squared theta. So that is that, and you can say that that's the same as that, so therefore you have shown that. So part C then, I think we go straight to part C from there, that's shown. Find the values of theta which give the greatest value of the sum. Tamara, I presume you didn't get this part, or did you? Or did you go for it?
No.
Nope. Sean, did you get an answer here?
I got an answer. I don't know if, well, I got 2 answers. I don't know if they're right.
Well, shout them.
Pi over 2 and negative pi over 2.
I think perhaps I don't think theta can be negative if you look at the start of the question.
Oh, right.
So yeah, you're on the right track though. So if we look at this, obviously, not obviously, we're going to use this one. They've done it this way for a reason. So we're going to look at this. 100 over 3 plus 2 cos 2 theta. Now for this to be the greatest, so this is the sum to infinity. So we want this to be as big as possible. So what value will cos 2 theta? What's the maximum value this could be, or a minimum, to make this a maximum number? So we probably want this to be a negative number, don't we?
Yeah.
To diminish the dividing. So the smallest negative number it can be is -1. So 3 plus 2 times -1. That's as small as that's going to get ratio-wise. So when we do that, that's 3 minus 2, which is 1. So that's 100. So that's that is the greatest value it can be. All right. So that's the greatest value, but we need to then make that match up. So see the actual angles that gives cos 2 theta equals -1. We want to find out what theta is. Now, where's cos -1? It's at pi, and 3 pi if you go that direction, or Sean, you went pi and negative pi. Those two places at -1, you can draw your unit circle if you want to do that. So if 2 pi is equal to that, what's or 2 theta is equal to that? One single theta must be both these divided by 2. Would we need another one? No, because our answers have to lie between 0 and 2 pi as given in the question, so we don't need to do any more than that. If it was 4 pi, you might need to go more, but it's not. Okay, so
okay. I just went the wrong direction. Okay.
Yeah, you did. Yeah. So, yep. Okay, and that's that. Once again, on the difficult side of that question, and does require you to know your trig, especially in part A2, and actually all of it pretty much. You needed to be quite comfortable with your trig. The last one is a compound interest question that brings in some geometric series. Now, all the questions were pretty much geometric series, not arithmetic. It's far more likely that you will get geometric than arithmetic. And it's also quite likely, in my predictions, that you will get a compound interest question. Similar to this, it seems to be on the cards. So let's look at it. That's just a hunch. I'm basing that only on a hunch. Okay, so this bill guy takes out a bank loan of 100,000 to buy this car, and it has a interest rate of 5.49%. So there is a compound interest formula in your formula booklet. So I might as well use that one for this. You probably may remember it from maybe year 10 or 11. This is the compound interest formula. So FV stands for future value. This is the present value or principal. And this is this K is the compounding periods per year. So if it compounds 4 times in the year, that's 4. If it's monthly, that'll be 12. And N then is the number of years. So hopefully that is a familiar formula to you guys. It should be. So let's work out Bill's amount of money he'd owe after 10 years. So 100,000 was his present value. 1 plus, you could probably combine this all into 1.0549, but we'll do it by the book here. The interest rate is 5.49. You're going to divide that by 100 then, and well, multiply it by 1 if you want, because there's no nothing other than once a year it's compounding, and that's 1 times n on the outside, and n is 10, so that's just 10. Stick that into your calculator, and I think you get, tomorrow, did you get an answer here? I don't know if you ever said anything, but I'll fill in the gap for you. Okay, so that's our answer for that, 170,000. So hopefully that was relatively straightforward. Part B then.
Part B, I did not understand.
Yeah, so to pay off the loan makes quarterly deposits of P at the end of each quarter, so it's quarterly into a different account. So, and the interest rate in this account is 3.2%. So he makes the first. So okay, so let's look at this. We don't know what P is, but we can perhaps look about how many times it's gonna. So over 10 years of this thing, he's gonna put in quarterly deposits of P. So that's how many deposits that gonna be. That's gonna be 40 deposits, I think. Okay. So this is going to form a sequence, I think. So the future value of this thing is going to be, well, after initially, the present value is going to be that first deposit of P. Then after another a year has passed, he's going to put in he's going to add to that P, but that P has gained interest, the first P, if that makes sense. So it's, what's the interest rate it's gained? Well, it's 3.2%, but that 3.2% is spread quarterly, so you got to divide by that 4. And that's its value after, at the, I suppose, start of the second year, or if that makes sense. Now, what would be after that? Well, then after that, the principal that has been there 2 years, I suppose, has done it again.
Oh, and then we just keep doing that.
Yeah, and then you can see that then that's a pattern. So each year, this initial principal is getting more, and the previous one's getting 1, and so on and so forth. And if you keep doing that, when would we finish?
And well, it's asking us for 10 years.
So it's 10 years. It is asking for 10 years, but we finish at the end of 10 years. This is not, sorry, I said a year. This is the end of the period it's compounding. So you've divided it by 4 here already. So you've taken, you're looking at 40 deposits.
Yeah.
So it's, would this be 40, or would it be 41 or 39, or would it just be 40?
It would be just 39 because the first one is P, right?
It is 39. So the first one would be, yeah, the 0 term, I suppose. It would be 1. It's the first term of the sequence. So it's 39 times that happens. And that's the tricky part of this. Now, if you put this bit into the calculator, you do get 1.008, which of course is 3.2 divided by 4 would be the 8 part. So what you are seeing here then is the it's the sum, isn't it? The sum of terms. So you can use the sigma notation if you wish, but you can just go straight to your sum of, because we have it's the sum to 40 terms. We have 40 terms, so we use the sum terms formula. Minus 1. So the ratio in this case is 1. This is the ratio, and this is the initial term. So it's just going to be P times 1.008. It's to 40 terms, so that's 40. That's where the 40 comes from. Take away 1, all over 1.008 minus 1. And that is what we were looking to find. All right, but that was, yeah, there's definitely a jump to get from here to here that required a lot of thought. So this was the hardest compound interest question I could find. So should be, if you're able to do this or able to understand this and do it again, you should be okay for compound interest questions. Okay, so given Bill's aim is to own an electric car after 10 years, find the value of P to the nearest dollar. So the 10 years, the electric guitar car, this initial amount was the price, wasn't it? So it's, you want this to equal that. So it's just a solving from here. You perhaps are able to do this because you have this formula. Did you get an answer here, Sean?
I got 3,637.
Yeah, so this is a calculator job, and so P is approximately equal to the nearest dollar. Yeah, 3637. Okay. Okay, part D, which did take me a while to get my head around. Sean, did you get this to work out? What was that?
I did not.
Did not. Tomorrow?
No.
Okay. All right. So this is a total new deal. It's pretty much a new question. Linda visits a different bank and makes a single deposit of an amount of money, an annual interest rate being 3.5%. So this is a bit like the way the first question sets up is, if you think about this a bit like a pension. How much money do you have to have in a pension so you can withdraw a certain amount every year for infinity?
Okay.
So the interest rate will compensate for the amount you're taking out, if that makes sense.
Yeah.
Let's have a little look at an expression for the investment after n years, and that would be the future value of it would be that initial money. I won't do the formula again. It's 1.035 to n. Right. Now, that must match the ability to take out $8,000 for up to a period of n years. So this must match. No. Oh, I keep writing 8. It's Q. Q times 1.035 to the n. So this must match what? How do we write that 8,000 over a course of n years? Well, 1 year is okay. So that'd be 1 year.
Yeah. Don't we want it to be just the interest part of it that's equal to that?
The interest part. So you're saying just
It's like if it's just 1 year, don't we want 0.035 times Q to be equal to that? Or are we saying that we just want the savings to be equal to that at the end of the first year?
Yeah, so if it was 1 year, we'd want the savings to be equal to that, but it's not 1 year. So what I did was I formed this sequence, which accounted for the interest.
Oh, okay, and that kept that to infinity.
And that to n number of years. We're not entirely sure how many years. That should be n. It'd be n minus 1, wouldn't it? Let me just rewrite that. The last term of that sequence would be 1.035 n minus 1. So Sean, you seem to have gathered this. Can you explain it? Why I've done that?
You've done it because we don't know how many years that it's going to be needed, but that's going to be how much money is taken out over how many years, and it's taking into account okay.
Yeah, so it's taking into account the fact that if there's 8,000 left for a year, it's going to get some interest.
Yeah.
Yeah, and if it's left for 2 years, it's going to get even more interest, and if it's left for n years, it's going to have even more interest. So it's like accounting for the interest on the 8,000s that are left each year, if that makes sense. And that was a jump. So this is the 8,000 taking out and the 8,000s that are all left interest. So it's trying to find an expression then for Q out of this. So if we know that Q with the interest taken into account equals that, Q on its own then is going to be all these terms divided by this. Isn't it?
Yes.
So I'll just write that part of it. 8,000 plus 8,000, 1.035 plus 8,000, 1.035 squared, all the way up to 8,000 on the term I've written there. Now, apologies for the small writing. Hopefully you can see that if it's on a larger screen. And that's now divided by 1.035 to the n, the interest compounding. Now that we're very close to having to show that, I think you can perhaps see that straight away we can write the actual thing we're supposed to show. That it was 8,000 over 1.035, 8,000 over 1.035 squared, and so on. If you want to split up this into each individual part, it's like you can write it in reverse if you want. Does that make sense? Yeah, so the last term then is going to be 8,000 divided by, so it's this term. So they've written it the other way around, 8,000 divided by this. And then the previous one is going to be 8,000 n minus 1. So this is one's gone, this is going to be 2 of them gone, 3 of them gone, and then it's like written in reverse, if that makes sense, what they have done. So the answer is there in the show that I'll write the answer here. So it is 8,000 divided by 1.035, which is this and this term combined. And then they have written it the other way around. And so on. Okay, so in order for the interest, so this is going to find an interesting answer in the next part. In order for the interest to keep up with this withdrawal of 8,000 every year, this is the hence or otherwise part 2. There's an amount that is like a, what's this, like the, I think, like the terminal velocity amount that you could put in at the start, and you can keep withdrawing 8,000 indefinitely. So as soon as you talk about indefinite, it's sum to infinity, I suppose.
Yes.
And you have this, so you could have done this part without showing this part. So the hence that, you know, that this is U1. We know that the ratio then is 1 over 1.035. That's the ratio. So if I just do a sum to infinity of that, the first term, 1.035 divided by 1 minus 1 over 1.035. Stick that into the calculator. That's going to give us that magical number. So this is often where you see in lottery winners and stuff like that. If you put in an amount of money, and perhaps that'll be the way they ask the question if they ask this again. If you put in an amount of money and you can, people say you can comfortably live off the interest for the rest of your life. This is the kind of setup, how much you're going to take out each year to be comfortable. Therefore, how much do you need to put in for an indefinite interest to carry you through for life? And that's what this question was kind of about, something similar.
Yeah, okay.
Yeah, but perhaps this is the first time you have seen this type of question. I would advise perhaps finding one from the textbook if that was an issue, and putting it. So if you're on the questions, I'm just going to stop recording for a second.